All right, this is our last exercise. So we're trying to find a definite integral of 4 secant theta tangent theta within the interval negative pi over 3 and pi over 3. So why don't you write the little f in terms of, or as a function of theta. So that is 4 secant theta tangent theta. Okay. All right, our goal is to find the antiderivative of this function. And you can use the differentiation integration formula card for this purpose. And we know that if you start with a secant function, and if you take the derivative of that, that's always secant theta times tangent theta. So for this function, the antiderivative should be 4 times secant theta. Right? Here the reality check is that if you take the derivative of the antiderivative, you should get down to the derivative. Right? So once we have the antiderivative, we can go ahead, write the value of the integral to be f of theta with the bracket notation from the lower limit to the upper limit, pi over 3. All right, this essentially means that you're evaluating f, capital F at pi over 3, and then you're evaluating capital F at minus pi over 3, and then you're subtracting them. Well, this is equal to 4 times secant pi over 3 minus 4 times secant of negative pi over 3. Go ahead and use your TI-84 that these terms take exactly the same value because secant is an even function. So you get exactly the same numbers popping up, and multiplying them by 4 doesn't change anything, so you get just 0. Can we relate this integral to the area between the curve of 4 secant theta tangent theta and the theta axis? So let's check that. All right, here's the graphical outlook of secant theta tangent theta. So our function was 4 times of that, but I just wanted to show you that secant theta tangent theta is symmetric with respect to origin, which essentially means that on the right of the origin, f takes the positive values, and on the left, f takes the negative values. So you have an area here between the curve and the x-axis. That's the integral from, so this area is the integral from 0 to 1 of, let's say our function is 4 secant theta tangent theta, so this is 4 secant theta tan theta d theta. Okay? And this area here is negative of the integral from negative 1 to 0, 4 secant theta tan theta d theta. Okay? But since these areas are exactly the same, so this integral from negative 1 to 0 is exactly the same as integral from 0 to 1 up to a sign. Okay? So in other words, when you add those two integrals, they cancel out each other. Or when you add the positive area to the negative area, they cancel out. That's why we got the integral to be just 0. So there's no area even to talk about if you want to sort of like relate the integration business to the area business. In fact, we do have areas in terms of the integrals corresponding to those areas. One provides us a positive number. The other one is the negative of that positive number. And when you add them up, the negative area cancels the positive area, so you end up having just 0. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.